All right, we are on to section 7.4, part 2. So this is our bigger part. Here, 7.4, part 2. So what we're going to be looking at now is what happens when we actually change the midline of a sine or cosine wave. And it's very actually fascinating to me that we can even do this. But look at so we have the A sine of B of t format. And then what we do is we change the area where we would normally put our midline. We make that into an actual function. Those are either the three main types of midlines. We can have a linear midline. And notice how that is just a line. And then our sine wave goes up and down over the top of that line. Or we can have an exponential midline. Or they can also have a quadratic midline. Now, I'll tell you now that we do not have any quadratic midlines in our homework assignment. The only two that you'll see are linear and exponential. And when you are writing your equations, remember your formats. So we'll have y equals mx plus b is the format for your linear. And then y equals a b to the t will be your format for your exponential midline. So they'll give you an extra piece of data in the story problems that were given for you to figure out what your midline is. And you're going to have to decide, is it either midline or linear or is it exponential? And then you have to write a second equation, and then we'll just insert that second equation into this place where the midline goes. Now also remember that on some of those problems, they had the midline written in front of the sine or cosine function. So just remember that, keep that in your mind. I think there's one example where that does show up. So keep that in mind. Our example number 1 is actually just a review of what we talked about in the last video for part 1. So this says the displacement of a mass suspended by a spring is modeled by the function h of t equals 10 sine 12 pi t, where h of t is measured in centimeters and t is measured in seconds. We need to find the amplitude, the period, and the frequency. So not too bad. Our amplitude always is going to show up right out here in front. So our amplitude is I forgot to erase my marks. Amplitude here is going to be the 10. So amplitude equals 10. And then our period is going to be 2 pi over b. So be careful with that. A lot of people, I noticed on the last test, are still kind of confused about this b value versus period value. So this is our b value here, the 12 pi. So to find p, we're going to do 2 pi over 12 pi. Now we have our period, which is 1/6. So down here we have p equals 1/6. And then just remember that frequency is the inverse of period. So frequency is 6. And that's all the answers they want for number 1. All right, and example number 2. We have a population of rabbits oscillates 33 above and below average during the year, hitting the lowest value in January where t equals 0. So notice this is, so far, sounds just like our other rabbit population equations that we have done. However, the next sentence then says the average population starts at 850 rabbits and increases by 130 each year. So this is maybe a little bit more of a real scenario where the rabbit population is over time increasing, even though it still has that same oscillation of 33 above and below average during the year. So when we graph this, it says the average population starts at 850. So I'm going to put 850 up here. This is the average population. But what does it say happens in January? At January, we are hitting our lowest value. So our midline is 850, but we are going to start 33 below that, which is going to be, what, 817? And then it increases by 130 each year. So by the end of our year, if we look at 1 year, 1 year's worth of time here, January, let's just say, let's go back here. By the end of the year, our population is going to be 980. So it's going to increase up to 980. But since it is saying that our highs and our lows are occurring in January, so this is also another January, then we're going to be 33 below that average in January also. So our midline is going to be here. Let's see if I can draw a straight line. That's our midline. And then, let's see here, so this is going to be our lowest, and then where's about our quarter points? Let's say halfway's about here, and then our quarter points. Oops, that wasn't a very good one. Let's go here for a quarter point. And so at our quarter point, we'll hit the midline again, and then here we'll be 33 above, and then we'll be back to our midline, and then we'll be back to our low. So to sketch our graph, and sketching your graphs really isn't a part of your homework assignments or anything. You're not really going to be asked. I'm just showing you this so you can kind of get an idea of what's going on. And usually we'll look at these over like 10 years period of time. And so your oscillations will show up a lot more frequently in that case. But this is just one little cutout of what 1 year would look like and how we would graph it. So we need to find the equation, actual equation for this population. So since we are starting at a low, I'm going to make that a negative cosine function. And then what was 17 was our, 33. Yeah, 33 above and below. So 33 is our amplitude. So negative 33 cosine of, so our period is, it takes 12 months to get through the whole year. So our period is going to be 2 pi, or our b value is 2 pi over 12, which is pi over 6 times t. And I'm starting mine right at 0, so I'm not shifting left or right any. And then our midline. Our midline is what now needs to be written as an equation. So this was a linear equation because the average population started at 850 and increased by 130 each year. So we could say that that midline is y equals 850 plus 130 t, where t is in years. And so we could write that here. So 130 t plus 850. Okay, I had to double check myself on that, and I was right. So, well, I'm wrong here, but I was right in what I was thinking second. So here I have t as in terms of months, and then here I said t was in terms of years, and we can't do that. So let's just go with months and say that this is 130 over 12, and then that will give you the correct answer. So make sure that your slope is consistent. Either do it in terms of years or in terms of months, but this is easier to change than this inside one is here. So just change that to 130 over 12 times t. And on example number 3, we have a population of rabbits oscillates 28 above and below average during the year, hitting the lowest value in January. The average population starts at 950 rabbits and increases by 8% each month. So this is my big clue right here, that this is going to be an exponential growth, that 8% each year. Find an equation for the population P in terms of months since January of T, January being T. So the average population, again, that means our midline, the average population starts at 950 and increases by 8%. So let's look at what our exponential equation looks like. We have y equals a times b to the t. So what do these values mean? Remember that a is our initial value. And that b is our growth rate. So if it is growing, we're going to do 1 plus 0.08. If it was decreasing, we would do 1 minus 0.08. So this one says that it is increasing. So the equation that we're going to write for just our midline is y equals our initial value, which is 950, times 1.08 to the t power. So that's the equation that we're going to have to tack onto the end for our midline. And then the rest of this, it said that we were hitting a low in January. So that to me means we're going to do a negative cosine. Also tells us that we're oscillating 28 above and below. That's our amplitude. We're working in terms of months again. And so we have pi over 6t. And then, oh, also, so yes, on this one, this is also good to note, that is increasing 8% each month. And so we are good on our midline. So plus our midline, which is 950, 1.08 to the t. And that's it. We are done with example 3.